Congratulations. If you are this far, you have completed 50% of this course. This is a huge achievement considering the content of this course, which is very, very exhaustive. In this week, we have learned numerical integration. Fundamentally, the technique of integration when instead of a function, we have given a bunch of discrete points. Numerical integration also, it gives us the framework for numerical solution of differential equation. And this part, this numerical solution of differential equation is the key, is the central theme of this course. Why? Because this is the part where most application comes. For scientists and engineers, most of the problem that we solve, we model them as differential equations, either ordinary differential equations or partial differential equations, but nevertheless they are differential equations. So in upcoming week, we will discuss both ordinary as well as partial differential equation and their applications. The assignments in this week will be related to calculations on integration. If you are now writing computer programs, then you should be able to do these calculations very easily. If you are not doing programming, then you have to do some tedious calculation work by hand. So I strongly suggest that you start writing at least some of the programs or use some of the programs that I am providing in these lectures. Compared to the previous week, this week we have talked a lot about computer programming. So I think it would be best in your interest that you practice some of the program. If you cannot do that at all due to some reason, at least practice some pseudocode. Numerical methods cannot be learned without programming. That is why I urge you that you practice program as much as possible. Now we have completed the baseline for numerical calculus. What is the baseline? Baseline is this interpolation, differentiation, and integration. Now it provides the baseline over which we will develop the solution of ordinary and partial differential equation, which, as I already said, are used heavily in modeling physical phenomena. So, in upcoming week, first we'll take up ordinary differential equation and ordinary differential equation based modeling and simulation, which are used in practical problem. In ordinary differential equation, there are also two major parts. One we call initial value problem, and another is boundary value problem. And we'll talk about both of them. First the initial value problem and then the boundary value problem. And from boundary value problem in next week, we'll move toward partial differential equation. You will see that there will be some connection between these two. Both these problems, initial and boundary value problems, are very important in modeling physical systems. And here, programming is must. Unless you do programming, you will not understand this at all. Furthermore, I'll suggest that this, apart from this programming, you also brush up some of your previous work on the analytical solution of ODE, especially simple ODE, first order ODE at least. You take up a mathematics book such as Kresge or similar, whatever you have studied in your first year, second year. You take up that mathematics book and study the first order ordinary differential equation, their solution and their plot, everything. In this week, the plot will be very important. So there will be quite a few plotting. Unless you plot the results of differential equation, it's very difficult to understand what is going on. So plots will be important. So it's better you try your hand in some plotting software. My preference is TechPlot, or you can use MATLAB, or within Python also you can plot. Any of this plotting software, you have to put your hand on this. So these are the prerequisites to use this ordinary and partial differential equation lectures properly. And without this ordinary partial differential equations, if you don't learn them properly, you won't be able to use numerical methods in modeling physical systems. Finally, you finish the assignment quickly so that we can move to differential equations smoothly. When lectures will be coming, you should not be working largely on the previous week assignment. So please finish that quickly. Assignments are very simple. It should not take much time. So you finish the assignments quickly. That's all for this lecture. Thank you, and I'll see you in next class.